Welcome to Techno Decode. In parts 1 and 2 of Prophets of AI, we discussed a few notable figures who pioneered the development of artificial intelligence, either tangibly or theoretically, or both. But we focused primarily on the theory of French philosopher Michel Serres and his work on philosophy of science and culture. In parts 3 and 4 of Prophets of AI, we will consider Serres' theory further, focusing specifically on topics of artificial intelligence, both in the ancient world in part 3 and the modern world in part 4. In part 3, we will look at sundials as ancient forms of artificial intelligence. This idea was expressly promoted by Serres, and he wrote about it in a philosophical context in his essay, What Thales Saw at the Foot of the Pyramids, and also his book, The Origins of Geometry, or just Geometry. Serres also examined this idea within the history of science in his essay, Gnomon. Sundials are devices that were developed and used by the ancient Babylonians, Egyptians, and Greeks, and they're capable of measuring time and Euclidean space. In non-foundationalist fashion, Serres gives import to the fact that sundials in geometry concern universals, and therefore they have multiple origins and foundations. Universals, like ideals, inform time and space, but are also independent of time and space. Universals can be discovered by a single culture within history, or independently by multiple cultures. Geometry, like mathematics in general, relies upon the creation of abstract space where ideal universal forms can be isolated from materiality and the background noise of the world. This is called abstraction, and it enables the formal nature of geometry and mathematics. Sundials utilize an upright stick that extends a shadow from the sun upon a connected clay tablet, often with designated markings. The upright stick is called a gnomon, and a tablet includes markings that designate time of day and the time of year in coordination with the automatic movement of the shadow. Sundials can serve as a clock keeping the time of day, but they more frequently in the ancient world were used kind of like observatories for monitoring the changing of the seasons in accordance with the equinoxes and solstices to form what Serres calls a geometric model of the universe. Notably, sundials utilize a stick and tablet, which are renditions of the formal one-dimensional line and two-dimensional surface. Sundials then combine linearity and tabularity. The compass or stylus and ruler or set square are further renditions of the line and surface combination. With a ruler and compass, one can construct the entire edifice of Euclidean geometry and perform each of the proofs in Euclid's Elements, which was the standard mathematical text for over 2,000 years before mathematicians developed non-Euclidean geometry and modern mathematics. Sundials also can be used to measure space using the mathematical concept called homothesis or homothety. The word geometry means world measure, and one can actually measure the world through the geometric principle of homothesis. The Greek philosopher Thales of Miletus is said by Greek sources to have first recognized this principle. Thales' theorem, or the intercept theorem or basic proportionality theorem, is about the homothetic concept that is at play and that can be observed in self-similar tetrahedrons at the foot of the pyramids. Serres offers two quotes that connect the legend of Thales with the Egyptian pyramids and the principle of homothesis. The first is by Diogenes Laertius, who says, Hieronymus says that Thales measured the pyramids by their shadows, taking the observation at the time of day when our shadow is equal to our height. And then the next by Plutarch says, the height of the pyramid is related to the length of its shadow, exactly like the height of any measurable vertical object is related to the length of its shadow at the same time of day. In other words, at the time of day when the gnomon's shadow is equal to its length, the shadow of all objects are equal to their length. One can, in theory, measure the length of all objects that cast a shadow because they are all homothetically related at the same specific time of day. Thales' theorem is demonstrated by self-similar triangles that resemble self-similar pyramids. It's also called intercept theorem and basic proportionality theorem. It was commonly attributed to Thales, but The idea was actually known to Babylonians and Egyptians. What's important about this theorem is the common ratio, or the same proportion of similar triangles. This is the same idea of why TV sizes are measured diagonally, so that a TV can maintain the same length to width proportion across different sizes or areas. This diagonal projection across scales exemplifies the property of homothesis. Serres says, at the foot of the pyramids, what Thales or anyone else perceives cannot be anything other than the objects of the same form in different dimension. The perception of the three pyramids unfolds in the space of similarities. This space is electively constituted in these sites. Each pyramid is different but the same. Like the triangles of Thales' theorem, similarity is the secret of the triple edifice, the secret of its construction. The pure knowledge implicit in their architecture is definitely homothety. In order to build the pyramids, one must have, but not necessarily know, Thales and homothety. Notably, this use of the Sundials' homothetic principle is for measuring space, but not time. Sundials measure time according to the gnomon's shadow through the course of the day and the year. That's just one use of the sundial. But to measure space with the sundial requires the precise timing so that one freezes time and then takes advantage of the sundial's extension through homothesis. As Serres says, Thales stops time in order to measure space. Additionally, it's important to note that the homothetic relation is the basic idea of the model. Modeling is a homothetic practice. Modeling or building a micromodel of a real-world macro model directly expresses the idea of homothesis. Serres says, geometry is a ruse. It makes a detour. It takes an indirect route to attain what goes beyond immediate practice. The ruse here is the model, constructing in miniature with a constant module, a summary, a pyramid skeleton. In fact, Thales didn't discover anything other than the possibility of reduction, the idea of module, the notion of model. The pyramid is inaccessible, and so he invents scale. Homothesis is the mathematical concept of self-similar shapes across scales. It's implicit in the idea of modeling, scaling, magnitudes, and dimensions. It can mean expansion and growth when zooming out to larger scales, but also reduction when zooming in to smaller scales. The replication of a model on larger and larger scales can be guided and traced along a diagonal, where the diagonal represents a scale. The notion of a model in general is homothesis. Models make the inaccessible accessible. They conquer great distances by bringing what is beyond reach to within reach. This is the way of magnifying or multiplying power. One can obtain a maximal result with a minimal effort. So to the extent that a micromodel faithfully describes a macromodel, models can extend power and influence beyond the tactile model out into the world and beyond into the universe. Homothesis can also describe the relation between a formal structure and its various submodels. The one and the many, the ideality encoded in materiality, the mono and the poly, or the simple and the complex. Homothesis is operative in the phrase, as above, so below. Geometric scale through homothesis ultimately is what allows for the science of geometry or world measure. A person can measure the entire world because of homothesis. Eratosthenes of Cyrene was the first known person to calculate the Earth's circumference using geometry, estimating it at about 39,375 kilometers or 24,662 miles, and that was around 240 BCE. So part of what's important about sundials, according to Serres, is not just its role as a clock. In fact, that's probably its least important function in the ancient world, according to Serres. Rather, sundials through the gnomon enable a universal system of measuring both time and space. And this creates a world system or a global format that's universal and non-foundational or cross-cultural. This is precisely why geometry has multiple origins in many different cultures in both the East and West. Sundials are an ancient artificial intelligence for automating a universal format that's aligned with measurable time and Euclidean space, but also imbued with perpendicularity and homothesis, as well as the principles of proportionality, ratio, reason, and logos that, via the sundial or its simple components, are accessible to virtually anyone, anywhere, at any time. The sundial then opens a universal rational format called the logos that puts the entire world into anyone's hands. In the philosophy of Michel Serres, all objects in existence interact with their environments in a variety of ways that he calls communication. Communication for Serres constitutes a very broad range of exchanges and interactions, and objects can think and organize data just like subjects can. To this effect, the gnomon of sundials, according to Serres, is said to discern or determine. As a result, through determinism, gnomons can produce certainty. The phrase used by the ancients, like the gnomon, references the perpendicular or orthogonal nature of the gnomon, rising up from a tablet at a right angle. The intelligence of the gnomon is its perpendicularity, or its right angle. Notably, the first three dimensions, which delineate Euclidean space, are defined by right angles that shape independent degrees of mobility or directions of movement, in terms of length, which is forward and backwards, width, which is side to side, and height, which is up and down. The gnomon also recalls the traditional plumb line that produces a right angle with a mason string held by a weight. So the phrases like the gnomon and according to the plumb line denote perpendicularity. Serres says the verb think in contemporary Romance languages has no other origin than the verb to weigh or to hang. The right angle also allowed gnomons to be used as set squares or framing squares or rulers from which one could replicate or extract a right angle or square. This feature of gnomons allow it to be used to determine complementary parallelograms or successive squares along a diagonal, exhibiting a characteristic called gnomonic growth. One can also fill in successive squares with number sequences according to a law of series or rule of sequence to calculate the square measurements. This is how the famous problem of the doubling of the square is demonstrated in Plato's Meno. Serres says that these results are given in a machinic, automatic way. The entire operation by which the gnomon discerns and produces information is completed without human interaction. The sundial performs all of its functions automatically in coordination with the sun and completely independent of humans. Serres says everyone recognizes two kinds of artificial object, those that don't depend on us and those that do. Only the first ones function unceasingly, or better, never stop being artificial objects. Examples include the wall and the roof, which always protect us, even when we're sleeping. But when we abandon the shovel and the pen, they sleep, useless and annihilated, intelligent only during our waking moments. In truth, real tools do not depend on us. The others rest too often to be genuinely entitled to that name. So to give the same name expressing knowledge to three automatisms, that of the post standing in the sun, that of the set square or the lateral band that is added and or removed, and that of the operation whose repetition constructs the series of numbers. This brings us back to artificial intelligence. So sundials are independent or artificial, and they automatically determine according to perpendicularity, or they are intelligent. Sundials, therefore, are artificial intelligence in the ancient world. Serres says, as an object, an arm which placed in an appropriate position will give astonishing results. Latitude, solstice, equinox, which it provides automatically. That means it works all by itself without human intervention, like an automaton, without anyone to operate it. Mechanical knowledge, since it intercepts a movement, that of the sun. Let us call it a machine rather than an instrument, as tool strongly implies the person who uses it, or the conscious and finalized action for which the person designed and made the tool. On the contrary, the mental activity indicated by the word nomon in Greek refers here to the machine, to an object. The nomon instantiates one of the first pieces of automatic knowledge production in history. It's the first machine to combine hardware and software. For Serres, he will align with nomon, memory, and software, and he'll also align table with tablet, the machine, and hardware. For Serres, the machine or hardware and memory or software are two components of mechanical procedure, which according to Serres makes for an, quote, algorithmic way of thinking. He notes that algorithms are not a new idea, but an ancient idea. He says, here is memory, there is the nomon, the table corresponds to the machine, mnemotechnics is associated with automatic knowledge. Likewise, in the science of the Babylonians, automatic calculation procedures exist alongside tables of measurement. In other words, and more generally, an algorithmic way of thinking always has two components, one which would be called mechanical and the other which would be called mnemonic. These can be described as an accumulation or recapitulation of the results of mechanical procedures or conditions of the repetition, the automaton in tables of dictionaries, hardware and software. Serres implies that in order to consider the nomon as an ancient artificial intelligence, we have to get past our preconceived modern biases in favor of subjectivity, and we have to also consider objects as drivers of knowledge and intelligence. He says, in the literal sense, the nomon is intelligent because it puts together situations chosen among thousands of others. Therefore, it discerns and understands. A passive receiver, it sees the light and then it actively traces the fringe of the shadow on the page while theoretically showing the model of the sky. In order that we moderns might gain access, once more informed by the nomon, to this automatic science, to this artificial intelligence, we should forget the philosophical prejudices of the modern interlude, where man is the center of the world, in the place of the nomon, the subject in the middle of knowledge, its universal receiver and driving force. In fact, nothing is easier than abandoning that complicated faculty to just read simply what the sun writes on the ground. And so Serres says, artificial intelligence is not new. From the beginnings of science, there have been things or states of affairs that the history of our languages associates with mental activities, as if these artifacts, like the nomon, the plumb line, the ruler or compass, the set square, these were considered as subjects of thought. So Serres argues that the objectivity of the nomon predates the subjectivity of the Cartesian cogito. He says, so when it comes to knowledge, our languages bring us back to the artifacts as simple and primitive as the plumb line, and the nomon tells us only that the human subject of thought is only recent. Artificial intelligence is more ancient than just intelligence. Thought of as a faculty of the mind, itself being reduced, as a word expressly indicates to a possibility of doing. I think is 300 years old, while the nomon has been saying that it knows for more than 3,000 years. So for Serres, intelligence is found in the mathematical idealities that are internal to material form. He says, quote, knowledge lies within the form. What does form mean for Serres? He says not only does form mean shape, face, edges, definition, and determination in the literal sense, but also the object's principle of organization. After all, when one inspects matter on an atomic level, one finds that, and here I'm quoting Serres, matter does not exist, only forms are found, end quote. So when one zooms into matter, one doesn't hit a wall where air ends and surface begins. Rather, the surface of the object disappears, and forms of arrangement and organization emerge from energetic fields. Energetic fields then act as underlying blueprints that organize form. Serres says, there is no matter in the universe, otherwise the physical sciences would have ended up encountering limits to their progress or their history, limits anticipated and set up by materialist metaphysics. So, for Serres, the advance of materialism ceaselessly finds forms without ever coming across matter, and it follows that intelligence is immanent and probably coextensive with the universe. The world provides a huge store of forms. In Plato's Meno, Socrates uses the problem of the doubling of the square to teach homothesis and the properties of the diagonal to a Greek slave boy who was knowledgeable of arithmetic but ignorant of geometry. In doing so, Socrates demonstrates that geometry is universal and that geometric knowledge is not learned, but is recollected via memory by a process called anamnesis. Recollection is the solution to the problem called Meno's paradox, which argues that learning is impossible, because if you know what you're looking for, inquiry is unnecessary. But if you don't know what you're looking for, inquiry is impossible because you'll never recognize it. One cannot move from ignorance to knowledge, according to this dilemma, unless knowledge is already present in the soul to be recognized and recollected through anamnesis. In the Meno, Socrates asks the boy if he recognizes the square figure that he draws in the sand. And the boy does. He recalls his multiplication tables and tabular knowledge generally, which is conducted by addition and multiplication with these squares. So Socrates asks if a square divided into 4 smaller squares is 2 feet by 2 feet. And the boy says yes. So 2 by 2 equals 4 square feet. Then, without guiding the boy, Socrates asks, how many squares are needed on each side to produce a square that's double the size of 4 with an area of 8 square feet? The boy answers 4. So Socrates doubles the square in this way, extending the square to 4 units on each side. However, this produces a square of 16 smaller squares, not 8. And so the boy suggests reducing the line to 3 squares on each side, not 4. But 3 squares times 3 squares equals 9 squares. So this doesn't solve the problem either. And suddenly the problem appears unresolvable because the answer would have to be between 2 squares on each side and 3 squares on each side. So the slave boy is perplexed and can't figure it out. So Socrates guides the boy back to the original 2 by 2 or 4 square foot square and notes the fact that multiplying the 2 sides in a multiplication table forms a product along the diagonal between the 2 sides. So Socrates points this out. The diagonal drawn end to end also produces 2 triangles that are each 2 square feet. So if the 4-foot square is then further squared by the same tactic, the diagonals in the larger square can then be rearranged to form the sides of an internal square composed of 4 2-foot triangles. And so this new square, the internal square, then is 4 times 2 square feet, which is 8 square feet. That makes this internal square on the diagonal twice the size of the original. So to double the square, one squares the diagonal and not the sides. This solution avoids the crisis of having to leave the world of rational whole numbers to plunge into the minutiae of irrationals between 2 feet and 3 feet on each side, which would gravely upset the rational logos and the global ancient format set up by the sundial and the gnomon. So where did all this begin? Well, Pythagorean mathematics relies upon and even divinizes rational whole numbers. The constant irritant of this brand of mathematics is irrational numbers because they thwart simple calculations. So the homothetic universe of rational logos is beautiful in its simplicity and magnificent in its universal hierarchical scale, but it has to work to constantly ward off irrational calculations. The Pythagorean theorem, which denotes a squared plus b squared equals c squared, requires that one angle is a right angle. However, the simplest demonstration of the Pythagorean theorem is also its most fatal, because it produces an irrational number as its solution. So, a square whose sides are exactly 1 unit, the most basic unit, produces a diagonal that is root 2. And notably, this is the simplest mathematical expression of homothesis according to the sundial as well, where the time of day of the gnomon's length and shadow are equal. So we can demonstrate the irrational outcome of this problem by apagogical proof. If we express the value root 2 as m over n, then using the Pythagorean theorem, root 2 equals m over n, from which we can deduce that m squared equals 2n squared. Now, if m squared is even, then that would also make m even. And so the first outcome is that n is an odd number. Now, an even square is divisible by 4, and that would apply to m squared. So therefore, 2n squared is also divisible by 4, and n squared is even, which would also make n even. So this produces an absurd outcome where n is an odd and even number, which is impossible. The square root of 2 then cannot be expressed as m over n. Since antiquity, this first demonstration via the absurd has been known as apagogical. Apagogical proof is an indirect method of argument that assumes the opposite case and then proves its impossibility. This is proof by contradiction, in other words, and it leads to a logical absurdity, or a reductio ad absurdum, or an infinite regress. Irrational reductions into the immeasurable go on endlessly in infinite regress, such that a reductio ad absurdum is also a reductio ad infinitum. But this simply shows the failure of primitive Pythagorean arithmetic, which only takes into account whole numbers, or to be more precise, rational numbers. So suddenly, space shows length, which calculation no longer includes. This is the world of irrational numbers and the immeasurable, which are exposed in the very first proof, the apagogical proof, which warned of imminent danger in the very first time any Pythagoreans first tried to figure the diagonal of a triangle whose sides were 1 unit. Hippasus of Metapontum was an early follower of Pythagoras, and he was credited in legend with discovering irrational numbers or incommensurable magnitudes via apagogical proof. Legend foretells that he was scapegoated and drowned at sea by other Pythagoreans who were outraged by his discovery. Serres says, the gnomon is formed by whole numbers, odds and evens. The gnomon knows only perfect squares, the perfect science of the logos, unaware of irrationals, the archaic and highly imperfect science of the perfect logos. The gnomon constructs the edifice of global rational knowledge according to scales, and it also conceals problems lying in the irrational gaps between rational numbers. So the rational logos is also pocketed with irrational alogos. Zeno of Elea famously extended the problem of irrationals through a problem called Zeno's paradox, which details the paradox of plunging into the infinitesimal in the course of traveling between 2 points. In order to travel from one point to another point, one must first pass through a middle point of the line segment that separates the 2 points. If one follows this mechanical pattern of passing through a midpoint of each remaining segment, and so on into infinity, then the traveler will never arrive at his goal. Rather, he'll just travel further and further into the minutiae between the endpoint and infinitely preceding midpoints. Each time the traveler passes through a middle segment, he passes homothetically towards the infinitesimal via a reductio ad absurdum, or ad infinitum. Serres says the world which we can measure as much as we like, either approximately or even exactly, borders immediately on another world which is infinitely remote without dimensions, since metric theory is exhausted trying to reach it. It's an absent hole in the drawing. In other words, the measurable world of the finite is bordered by the immeasurable world of the infinite. This backdrop region beyond the finite is the place of the infinite, geometric abstraction, and the ideal. Serres says Zeno's scenario leads infinitely from the concrete representation of the metric formula to the surroundings, to the limit, the non-representable ideality, which cannot be drawn or written, subtracted to the point of exhaustion from all apprehension, visited or visitable points with an invisible, inaccessible goal. The abstract lies at the heart of this abyss, infinitely far but infinitely near. Reductio ad absurdum or ad infinitum is a path into the immeasurable and leads into the irrational, the infinitesimal, abstraction, the ideal, chaos, background noise, but also the third man. An early Greek example of reductio ad absurdum is the third man argument, which was famously raised by Plato himself, but later used by Aristotle to object to Plato's theory of the forms on the basis that it leads to an infinite regress. Serres turns this argument around by using the third man as a figure who marks a reductio ad infinitum into noise, chaos, abstraction, the ideal, and the infinitesimal. For Serres, the universal nature of geometry and mathematics makes them akin to the divine to the extent that formal mathematics exists in the ideal, non-physical abstract, but informs the material physical realm. So both monotheism and the rigorous sciences are two transcendent universals. He says that pre-Socratic philosopher Anaximander made this connection thinkable through his concept of the apeiron, or the infinite. Early pre-Socratic thinkers famously ended polytheistic religion and commenced the era of science by rejecting the notion that the world was created by gods, and they insisted instead that matter was constructed bottom up from the elements themselves and could be explained by rational hypothesis. The pre-Socratics, starting with Thales, replaced mythos with logos. One by one, different pre-Socratic thinkers posed a different element as the most fundamental element for composing matter. So Thales started this and said that matter was created from water, but Anaximenes said it was air. Then Heraclitus said it was fire, and Empedocles said it's a mixture of all of the above, fire, water, earth, and air. But then, interesting, Anaximander said, no, it's the infinite that creates everything, the apeiron. The infinite creates the finite. The boundless creates the bounded. The limitless creates the limited, and the indefinite creates the definite. Serres says, Anaximander doesn't propose one of the individual figures of polytheism for the non-definite apeiron, for such an individuality isn't conceived as boundless. Zeus's power limits Poseidon's. Athena is opposed to Aphrodite's schemes. He doesn't attain the god of monotheism either, insofar as the latter remains a person, but he's headed towards it, as Zeno, the founder of the Eleatic school, did. Beyond individual boundaries, Anaximander therefore generalizes the divine impersonally, spread everywhere without border, ubiquitous, eternal, unengendered, generative, space, time, power. So the infinite universe bears witness to the divine. It shines with it or sings it through the epiphany, bright or nocturnal, of the boundless firmament, as well as through the changing beauty, spring-like or winter-like, productive or destructive of the world, various definite profiles of the divine infinity. So, according to Serres, Anaximander generalizes the monotheistic concept by depersonalizing it. The infinite creates is encoded within the finite. Here, generalization is the process of identifying an underlying rule or pattern. It can be used to oppose a position as a substructure of a larger structure, or to confirm an underlying theme from a variety of local cases in a one-to-many comparison. The common thread among all the local cases of historical monotheistic gods is their infinite character. Anaximander deifies the infinite, the apeiron, as a singular creator of the physical world. And so this is why Serres says, Anaximander's apeiron is a prename of God. Serres says that on this foundation of the infinite, we can henceforth conceive of rational laws or a logos of the world. And so the infinite is the foundation for the finite. Serres says monotheism doesn't generalize some triumph of injustice to time and space, but conceives of what precisely has neither place nor time. It's not until the advent of the one God that the expanse suddenly becomes empty and no locality stands out against the homogeneous universe. A being beyond beings, here's a smooth universal which makes the natural and technical sciences possible. Openness and oneness abolish all peculiarity. The alliance, in other words, of a formula with phenomena open to experiment implies that the dogma of incarnation has been accepted. In other words, God is not a judge here, but the idea of the limitless, the boundless, the unconditional, and the finite, which gives birth to and allows for the finite, the physical, and the measurable, and the development of the measurable. And so the infinite gives rise to what can be measured, what becomes the science of measurement. So divinity for Serres is marked by its objectivity and its independence from subjectivity, which allows for a close relation between religion and physics. This reverses the modernist impulse to position religion and physics as fields that are opposed to one another. An absent God, indifferent to human relations, has the same status as the cloud of atoms in that their actions as individuals or as a group remain eternally independent of whatever drives people. So the natural object takes the place of God and can even coexist with him in that same place, the vital thing being to have a clear understanding of that place. Scientists believe in the existence of an outside world as a monk believes in God. Neither can prove it, but they cannot exercise their faith or their science without this fundamental belief. So remember that according to Serres, matter does not exist, and both religion and science draw from two transcendent universal fields. And so the scientist is just as religious as the theologian. Serres' position on objectivity is in stark contrast to postmodernism, which heavily favors the reign of subjectivity and social constructivism, and is skeptical of the idea of universal truth. But instead of rooting knowledge into the individual subject, as Descartes does, Serres favors the transcendent place where God coexists with the objects of the world, mystical experience, and experimentation. The pre-Socratics initiated a shift from mythos under polytheistic religions to logos under monotheistic religions. In this shift, Serres says that humans adjusted from being sociologists to physicists. That is, mythic societies were concerned mainly with human relations, not physical relations. And so numbers and arithmetic in these societies were primarily used for calculating the exchange of goods and for economic purposes among the human community. Mythic traditions also often included sacrificial scapegoating rituals to remove sacrificial victims from the collective as a social organizing mechanism. And this issue is explored in more detail in Prophets of AI Part 2. The sacrificial victims could be central authorities such as kings who were blamed for natural or social chaos and then condemned at trial and publicly executed, or their human or animal substitutes were executed as scapegoats. These ancient practices acted as ritualized safety valves that released social angst and pressure. They were the result of mechanics of hierarchy and rivalry or hierarchical struggle at play in those societies. In the end, these techniques, though violent and unpleasant, could be said to be a humane gesture in that they probably saved lives on the whole by reducing the social angst and social furor, which would have led to greater loss of life. The main idea is that these societies were not preoccupied with features of the physical world that more or less operated independent of their control. Rather, they were more preoccupied with social relations. At most, they can only be said to naively blame scapegoats for any chaotic injustices that resulted from the natural world and its brutal indifference to human affairs. Serres says, We have interpreted religions and mythologies in terms of the natural sciences for so long, a misinterpretation imposed by our modernity, that we still believe firmly that our ancestors were primarily afraid of lightning, meteors, and the dark, and of the sterility of fallow land. No, they feared others, and they feared the group, their enemies. All mythologies and religions are human sciences in an exquisite way, infinitely more precise, effective, and sensible than what we call by that name today. In the shift from mythos to logos, humans became physicists, Serres says, using math to measure the world of natural objects and physical relations outside of human societies. Under the logos, a scientific community organized around the study of natural objects through the rational logos, a universal format based on proportionality, which discerns the rational from the irrational independent of humans, and around which formed a scientific consensus that rejected or expelled from its community those thinkers who didn't fit within the consensus, and many of which, according to Serres, were also scapegoats, like Hippasus. Otherwise, the community advanced according to equality, which it derives from the rational logos and geometry. It's presumed under the rational logos, for instance, that all beings can equally verify universals like foundational mathematical axioms or geometric proofs and measures. Reason and equality are linked in the universal. In an interesting way, the beginnings of the idea of science with the early pre-Socratics, who founded the proto-scientific model of creation according to the elements themselves, water, fire, air, and earth, and not supernatural polytheistic beings, this does not dispense with the idea of religion entirely by rejecting polytheism. Rather, it initiates and rebirths a new form of religion in monotheism. And so the poly just becomes the mono. This is not the end of religion, but the restoration and return of religion after returning back to its transcendent origin to produce a monotheistic God. It's not some historical personal God, fetish, or idol, but rather the idea of the boundless, the limitless, and the infinite. Serres says, like Anaximander, we never cease to live the origin of religion. So religion and math are in fact percurrent and eternal. The alliance between monotheism and math posed by Serres has also been analyzed by other philosophers under the term ontotheology. This term combines ontology, or the study of being, with theology, or the study of the divine, or God. Ontotheology, which was analyzed by German philosophers Immanuel Kant and Martin Heidegger, refers to the idea or schematization of centralization, where God is used as the ultimate foundation or highest being within a metaphysical system or hierarchy. This logic reaches its climax in the 17th and 18th century Age of Enlightenment, where an absent, deistic, independent creator grounds the scientific enterprise in the triumph of reason in a simplistic, rational, proportional logos. The monotheistic, universal, rational logos holds the irrational, immeasurable, and incalculable at bay. It dwarfs them in glory, majesty, and light, a universal smooth that erases the particularities and chaotic peculiarities of the irrational and the immeasurable. This solar myth begins with the gnomon and endures through the Age of Enlightenment, where religious zeal simply passes over into and is replaced by the over-optimism of classical scientists. Ontotheology was redefined in the post-foundationalist, postmodernist era in the 1960s movement called Death of God theology, which, following Nietzsche, surmised that belief in a transcendent God is obsolete in a secular world. Death of God theologians promoted Christianity's adaptation to secularism by redefining faith without a supreme being. Soon after Nietzsche announced the death of God, mathematicians Cantor and Russell announced the crisis in foundations in mathematics in the early 20th century, following a string of foundational paradoxes in mathematics that led to the development of more abstract forms of mathematics, such as number theory and set theory. Serres says, it's no quirk of history, the tragic and fatal fact that just when the death of God was announced, The objective world lowered its barriers, removed its obstacles, lightened cruel and ancient necessity, began to lose its battles against our aggressive and triumphant technologies, and retreated, humiliated, behind our representation. In short, entered its death throes. The two transcendencies leave the same place around the same time. Now we have to write a philosophy of the death of transcendental objectivity. So Serres notes here that just as the death of God ensued in the late 19th century, early 20th century, 20th century also saw the death of the scientific transcendental as well, based on the rational logos. So to recap, sundials were ancient artificial intelligence technologies that automatically constructed a universal format of measurement and rational logos that sustained the development of the rigorous sciences against a smooth universal backdrop of monotheism up through the modern period. In part 4 of Prophets of AI, we will look at Michel Serres' characterization of modern artificial intelligence and how it differs from ancient AI, and how the roles of technology and divinity have changed in modern times according to Serres.